All right. Good morning, Trisha, Michael, John, Christian, and Prince. Welcome to this week's edition of Math 155. And no look now in just ilan na lang ba? In just 4 days, it's gonna be May na. So maglilipa na tong mga memes like this one. So and then that means we need to plan. Though I think the semester will will spill into June kung tama yung bilang ko. But in the short term, I think we can finish the uh, the third unit of the course siguro by next week. So that means I can give you the problem set as early as next week. All right, probably Friday next week for you to work on it. I'll give you probably 1 week to finish it. I-double check ko lang kung ano yung ginawa ko during the problem set one. But it will cover units 2 and 3, right? Limits of sequences and limits of functions. So lumped together into one problem set. My target is to give it next week. Kaya lang, I understand ang laki ng overlap nung mga students sa 175 and Math 155 because that would be a problem for me because I think I can also finish the current unit namin sa 175 next week. So magsasabay yung problem set, which is a bad thing dun sa mga tinitake, yung parehas na courses sa akin. Unintentional yun, guys. Sorry about that. Pero let's see, ano kayang magandang gawin? Uh, if you have some suggestions, lagay nyo sa chat. Or kung kaya nyo naman ng dalawang problem set ng sabay, kasi ganyan naman kayong mga online online students, ano, so sanay na kayo sa sabay-sabay na requirements. But if you have some suggestions how to work around it, please let me know kasi pinag-iisipan ko talaga ano yung gagawin ko kapag ka magsasabay sila. And I think that will happen for problem set number 2 for both courses. Okay. So, right. But I'll also think about it and give you an update, especially dun nga sa mga students na taking 155 and 175 under me this semester. Okay. Last week we talked about limits of functions. All right. Tiningnan natin paano natin in-extend yung definition ng limit ng isang function para mag-cater sa mas malaking class ng functions. In Math 36, we just defined the limit of a function who are defined on some open interval containing the number c at which the limit is being evaluated. But that is kind of restrictive kasi may mga functions na magandang i-analyze yung limits pero hindi sila necessarily defined sa isang open interval around the number of interest, right? So nakita natin, madali lang yung remedyo pero kailangan natin yung konsepto ng limit point. So sabi natin, okay, pwede ka mag-evaluate ng limit ng isang function as the variable approaches any limit point of the domain. All right? Kasi sufficient na yon para i-analyze or magkaroon ng isang magandang analysis ng behavior ng isang function. So that frees us up from requiring the function to be defined in some open interval. Pwede na nga lang siyang isang interval na ang left endpoint ay yung number c na ating kino-consider because it's still possible to be a limit point. Kahit mula lang sa kanan o mula yung sa kaliwa, yung mga elements ng domain na nag-accumulate dun sa given limit point. Right? And then I think last Thursday we weaved together we wove together the concepts of limits of a function and limits of a sequence. Na ito pala yung isang magandang bridge between those two concepts that will allow us to capitalize on the results that we have proven for limits of sequences, right? Kasi nakita natin na theorem 3.1, kapag ka meron ka palang isang function, yung limit niya as x approaches c will be equal to L if and only if any sequence in the domain that converges to the number c, right? Ang limit din ng kahit anong sequence na yon ay equal kay L. And it's a biconditional statement. So it's a characterization. So makikita niyo yung parang equivalent, sort of, ng limits ng function at limits ng isang sequence. And corollary to that theorem is a criterion for discontinuity. Sabi natin, madali magpakita na, hindi pala discontinuity, for limits, right? So masasabi pala natin na isang function ay walang limit as x approaches an accumulation point, say C, kapag nakakuha ka ng dalawang sequence sa loob ng domain that converges to C, but the function values does not converge, or the sequence of function values does not converge to L. So yun yung tinignan natin, and then we took advantage of theorem 3.1 pag-prove ng algebraic limit theorems, okay? And you can extend this to virtually any theorem that you have for limits. Kaya nyo siyang ibaba sa sequences. We can take advantage of theorems from Unit 2. So basically, that's what we have. And we will continue this trend as we go along Theorem 3.3. So Theorem 3.3, sa Unit 3.3, ang atin namang i-extend ay yung konsepto ng continuity. So we'll start this section by a comparison between how continuity at a number was defined in Math 36 and how we will define it in 155 para mag-cater sa mga mas malaking class ng mga functions, all right? So let's see, definition 3.4 is probably what you met in elementary calculus. So again, you have a function f that is defined in some open interval. So yun yung domain niya, ang codomain ay R. Then we say that f is continuous at a number x sub 0 in the interval, if and only if the limit of f of x as x approaches x sub 0 ay equal sa function value ni x sub 0. So basically, yun yung sinasabi natin na continuity at a number. And the way the definition was phrased allow us to have sort of a visual understanding or a visual criterion kung kailan continuous ang isang function. All right? So sabi natin continuous ang isang function kapag kaya mong i-drawing yung graph niya without lifting your pen. All right? Now, that means that the function will be continuous at every number on that x interval kung saan na i-drawing natin yung graph ng function without lifting our pen. But this characterization actually will work, or actually works, because the domain na ina-assume natin para dun sa function ay isang open interval. But the realization or that visualization of continuous functions will not necessarily work for us now kasi mas malaki na yung class ng functions kung saan kino-consider natin yung limit. Remember, hindi natin nire-require na open interval yung domain ng function. Okay? So yun yung mga babantayan natin. So at this stage, I will urge you to sort of do not rely too much on the graphical criterion that we develop in 36, or our intuitive notion of continuous functions na i-graph mo without lifting your pen, then continuous siya. Makikita natin later, may isang example na yung graph ng isang function ay hindi natin kayang i-drawing without lifting our pen, but per the definition that I will introduce in a second, siya ay continuous pa rin. Okay? And you will see na ang pinakakaibahan talaga yung domain of definition. Right? Now, speaking of the definition ng 155 ng continuity, we have definition 3.5. But you will see that this is not too much different, except na talagang ang nangyari lamang ay pinalitan ko yung domain. Okay? Hindi na siya open interval, pero pinalitan ko lang siya ng isang requirement. Ano yung requirement na yon? Dapat siya ay isang limit point. All right. So here we say that f, or we assume that f is a function defined on some subset of real numbers, and it is continuous at the point x sub 0 if and only if for every epsilon greater than 0, there exists a delta greater than 0 such that for any element in the domain with distance less than delta away from x sub 0, then we are guaranteed to get the epsilon inequality. Now, how does this differ with our limit definition? Kamukhang-kamukha siya kasi epsilon delta pa rin naman yung nakikita natin dito. Well, you will notice na nagdagdag lang ng phrase na ito. Okay? Actually, hinighlight ko lang to pero ano siya, part siya nung nung implicitly part siya nung assumption nung definition ng limit, alright? Tapos ayun pa rin, may delta inequality pa rin tayo rito. Yun nga lang, yung epsilon inequality instead of the number L na, instead L na yung nakalagay na subtrahend doon sa absolute value, f of x sub 0 na lang. But it mirrors the math36 definition na yung limit ng f of x ay equal dun sa function value para siya ay maging continuous. So basically, nothing big departure. There's no big departure from the math36 definition. Yun nga lang katulad to ng ginawa natin sa limit. Tinanggal natin yung restriction dun sa domain. Pinagaan natin ano yung kailangan para makapag-define tayo ng continuity para sa isang function na ang domain ay hindi necessarily isang open interval. Okay? So if you are to prove continuity using this epsilon delta definition, then we'll just do the same thing we did from for limits, except na yung L function value na nung x sub 0 under f yung gagamitin natin. Okay? All right. So let's try to illustrate that. Let's do example 3.5. This is your function g. It's a piecewise function. It's x times sine 1 over x when x is not equal to 0. And it is x equals 0. It is 0 if x is equal to 0. And we want to show that this is continuous at 0. Okay, paano siya maging continuous sa 0? Well, tignan natin to. Gagamitin natin yung definition. And again, we need to do a preliminary analysis here. Siguro dito na lang sa kabila. Saan ko ba makikita yung function? Sige, dito na lang. All right, so preliminary analysis. So we will assume that we are given an epsilon greater than 0, and we wish to find a delta greater than 0 such that for all x in the domain, but in this particular case, our domain is R. Kasi binigay nga ba sa function? Walang binigay sa function ng domain, and our convention in class is that we will select the biggest possible set for the domain, all right? And if you look at the function, kahit anong x, kahit anong real number can serve as the x in this particular function. So our domain is R. So dapat sa kahit anong real number, dapat mag-hold itong implication na to. Kapag yung absolute value ng x minus x sub 0 ay between 0 and delta, dapat mag-follow na yung g of x minus g of 0 must be less than epsilon. All right? So maghanap tayo ng delta na itong implication na ito ay magiging totoo. All right? Or by the way, our x sub 0 here is 0. So palitan ko na ito ng 0. Oops. Okay. Now, mula dun sa premise o dun sa antecedent no conditional statement na gusto nating ma-attain dun sa proof, right? Makikita natin kagad na absolute value of x is less than delta. All right? So our goal is to write the epsilon inequality or the left-hand side of it to be something involving the absolute value of x. Kasi alam na natin yung ipapalit dun sa absolute value of x. Kaya natin siyang palitan ng delta. Remember, our goal is to have a bound for this absolute value, possibly in terms of delta, and then force that upper bound to be less than epsilon to guarantee the satisfaction ng consequent nitong conditional statement na ilalagay natin later dun sa proof, right? But the quick substitution will tell us that g of x minus g of 0 is just equal to what? It will just be equal to, actually, it will be of two cases, right? So, kailangan ko pala siyang hatiin sa dalawang cases. Kasi yung function value niya ay mahati sa dalawa. Okay, but that is not a big problem. So if x is equal to 0, then we have g of 0 minus g of 0. That's 0, which is less than epsilon for any epsilon greater than 0. So wala tayong problema kapag ka si x ay naging equal kay 0, right? Kasi sure na tayo na kapag ka si x ay 0, achieve na itong inequality na to. Kasi magiging 0 to, which is definitely less than any positive number. Okay? The more challenging part is that if x is not equal to 0, okay, yung g of x natin ay mapapalitan ng x sine of 1 over x. But still, you're right, your subtrahend here is still g of 0, right? Kasi yun yung nasa definition. So sa lahat ng element ng domain, yung g of x minus g of 0 must be less than epsilon. So it doesn't matter what x you're considering, yung subtrahend ay laging g of 0. But per the definition of our function, ang g of 0 ay equal lamang kay 0. So ito yung meron tayo. But remember, babalik ka dun sa delta inequality. Yung delta inequality gave us a bound for the absolute value of x. So, ang target nyo ngayon, yung g of x minus g of 0, kailangan masulat ko in terms of or involving absolute value of x. And that's easy because I can just factor it out. Sulat ko siya ng ganito. Okay? And then now I know from the delta inequality, yung absolute value of x, pwede kong palitan ng delta. Alright? And then, ang problemahin ko na lang ay yung absolute value ng sine 1 over x. But that is not a big problem because it's just a sine function. Ang sine ng kahit anong number, however big or small the number is, the sine value is always bounded above by 1 and bounded below by negative 1. So it doesn't matter how complicated the argument of sine is, kapag ka meron kang sine, laging hindi yan lumalampas ng negative 1 at saka 1. So that means this guy is bounded above by positive 1, right? And so if we want this guy, the absolute value of g of x minus g of 0, to be bounded above by epsilon, then we will force delta, which is this guy, yung nakuha natin na bound, is less than epsilon, or less than or equal to epsilon. All right? And that's how the proof was written. I think in the proof, consider siya ng arbitrary epsilon, pinili niya si delta to be equal to that choice of epsilon. And the rest here is just the preliminary analysis written in a nice way or in an appropriate way. Okay? Kaya lang medyo may kulang yata dun sa proof ng na nasa handout kasi diniretso niya ng g of x minus g of 0 ay equal kay x times sine 1 over x. But this expression is meaningless if x is equal to 0, right? Kasi magkakaroon ka ng 1 over 0, undefined na itong left-hand side. Ang usapan sa definition, it should be true for all x in the domain. So if I am to write the proof, I would have split this into two cases. As we have seen in the preliminary analysis, consider the case that x is equal to 0 and the other case when x is not equal to 0. Maybe, hopefully I won't forget it, but in the next iteration of the lecture notes, idadagdag ko yung case na yun, right? Just to give a complete picture for the proof. Okay? All right, so I think that proves continuity, okay? So makikita nyo hindi malaki yung pinagkaiba nito mula dun sa pagpo-prove natin ng limits. Yung sa limits, L yung pinapalit nyo. Kasi kapag ka meron kang isang function, yung limit niya ay hindi necessarily yung kanyang function value. Alright? Pero kapag ka-continuous yung function, f of function value na nung limit point yung ilalagay nyo dun sa definition ng limit. Okay? So, any questions so far? Or masyadong madali? Elementary pa to, sir. Ito pa yung ginawa namin ng 36. So, I guess that's fine pa. Okay. Okay. Now we go to remark 3.5. And this is the thing that I'm telling you kanina na hindi na gagana under our definitions yung condition na yung visual criteria natin na pagka meron kang isang function na kaya mong i-drawing without lifting your pen, that would be continuous. Well, that is still true, right? Kapag kaya mo siyang i-drawing without lifting your pen, then yeah, continuous pa rin yun. Pero the converse will not will now not work. Bakit hindi na siya mag-work? Kasi meron tayong example 3.5. Merong mga functions na continuous by definition, under the Math 155 definition, pero hindi natin kayang i-drawing yung graph niya without lifting our pen or without, a literal lifting of the pen. So basically, failure to draw the graph of the function without lifting our pen or the impossibility thereof is not sufficient to conclude non-continuity or yung tinatawag natin na discontinuity. All right? Kita natin to sa example 3.5 or sa remark 3.5. It tells us that any function is continuous at isolated points of its domain. Right? Kapag meron kang domain, remember ano nga ang isolated points? Natatandaan niyo pa ba? Sige nga, can anyone remind me ano yung kailan nga nagiging isolated point ang isang point sa isang set? Uy guys, kinalimutan nyo na. Paano na yan? Mahilig pa naman ako sa sa pag-i-integrate ng mga units, mga chapters. So watch out for little details like that. Hilig ko yan. Pagtahi-tahiin yung chapter 1 sa chapter 2 sa chapter 3 and so on. But thank you, Ayesa. That's great. Thank you for remembering that. Ang isang isolated point ay kahit anong point na hindi limit point ng isang set. All right? So, ibig sabihin, if we will translate that further, siya ay isolated point kapag merong isang neighborhood nung domain na siya lang yung nag-iisang laman. All right? So, sa isang open interval, walang isolated point. Sa open interval kasi, pag kumuha ka dyan ng isang number na malapit dun sa left endpoint, pag nag-zoom in ka, lahat pa rin ng epsilon neighborhood ay magkakaroon ng elements ng open interval. Right? Pero halimbawa, si set n, pag meron kang discrete set, halimbawa si n, 1, 2, 3, 4, 5, and so on, lahat ng elements ni n ay mga isolated points. Bakit sila mga isolated points? Kasi hindi nga sila limit point. Dahil hindi sila limit point, kaya nating makahanap ng isang epsilon neighborhood centered at them na wala ng ibang lamang element ng set. Right? So ang set natin ay n. Kunin mo yung 1/2 neighborhood around 1. Yung 1/2 neighborhood around 1, wala nang ibang natural number na laman except for 1 itself. So that means 1 is not a limit point of n. Actually, n doesn't have any limit points. So therefore, all points of n are isolated. Okay? Tapos, yung mga sets na puro isolated points yung laman, papasok pa rin siya dun sa definition natin ng limits and continuity. Kasi ngayon, halimbawa, ito, n. Pwede na natin pag-usapan kailan nagiging continuous ang isang sequence. Alright? Kasi nga, wala tayong restriction na dapat define sa isang open interval yung isang function para magkaroon lamang siya ng limit. Pwede siya basta kahit anong domain, kahit ano yung domain niya, basta mag-evaluate ka ng limits sa kahit na anong limit point. Okay? So actually, if I will say that, mukha pa lang, wala pa rin palang sense yung continuity doon sa, wala pa rin sense yung continuity sa sequences. Kasi nga, kasi walang limit yung sequence kasi nga kailangan limit point yung x of 0. So kung meron kang sequence, we cannot talk about the limit of the sequence as x approaches 2, for instance. Kasi dapat si 2 ay accumulation point o limit point nung ating set. Pero obviously, si 2 ay isolated point, so we cannot evaluate the limit of a sequence as the variable approaches 2. Kasi si 2 ay hindi nga limit point. However, meron kasing loophole yung definition. Pero I think binanggit ko to kanina kasi intuitively on my mind, dapat nandito siya. Pero mag-stick tayo dun sa definition 3.5. And actually, it doesn't require x of 0 to be a limit point. Okay? Kasi nga, hindi necessarily na limit siya. Kasi rito, kung mapapansin nyo yung continuity, it doesn't talk about limits. That's how generic definition 3.5 is. Yung Math36 definition natin, kinailangan natin yung konsepto ng limit para ma-define yung continuity. Okay? Pero generic yung continuity natin ngayon. Hindi siya dumaan sa definition ng limit. Dumiretso siya. Anong sinabi niya? Eto, there's no requirement on x of 0. X of 0 needs only to be an element of the domain. Tapos, the definition acknowledges the fact that since we do not require x of 0 to be a limit point, there might be no limit for f as x approaches x of 0. Pero hindi pala yung kailangan sa definition kasi kailangan ko lang yung function value, ipalit ko siya dun sa epsilon inequality, then we're good. Okay? Ito yung loophole na gagamitin ko na kahit walang limit, ang isang function sa isang limit po sa isang isolated point ng domain ay posible pa rin pala siyang maging continuous. Kasi the way we define continuity, it is sort of independent to some extent to the notion of limits. Kasi yan yung makikita natin sa illustration na ito. So halimbawa, mag-consider tayo ng isang function na ang domain niya lamang ay tatlo yung laman. 1, 2, and 3. Okay? Tapos ang function value ni 1 ay 1, function value ni 2 ay 3, function value ni 3 ay 2. Right? So para siyang truncated sequence. Yung tatlo lamang yung points dun sa ating function. And then here we want to show that f is continuous at 2. In Math 36, automatic conclusion, the limit doesn't exist as at x approaches 2 because we cannot find an open interval. We cannot find an open interval containing 2 at which the function is defined. All right. So tapos yung definition yun ng continuity sa Math 36, dapat yung limit ay equal sa function value. Eh hindi nga nag-exist yung limit, so automatically hindi siya continuous sa 2. Pero ngayon, sa Math 155, we can say that f is continuous at 2. Bakit siya continuous? Kasi titingnan lang naman natin yung definition, right? So sabi, okay, bibigyan tayo ng epsilon. Any epsilon greater than 0. Tapos maghanap tayo ng delta such that whenever x minus 2 is less than delta, then f of x minus f of 2 must have absolute value less than epsilon. All right? So pag binigyan tayo ng epsilon greater than 0, actually, pwede kong piliin yung delta to be equal to 1/2. Kasi pag nangyari yon, ano lamang ba yung mga elements ng domain na makakasatisfy ng condition na x minus 2 less than delta? Or the absolute value of x minus 2 is less than delta. Eh, sabi natin ang delta ay 1/2. So, kailan ito mangyayari? Dapat yung layo ng x mula kay 2 ay equal kay 1/2. Pero gaano ba kalayo si 2 mula sa mga kapitbahay niya? So 2 is 1 unit away from its neighbor to the left and its neighbor to the right. So ibig sabihin, isa lamang yung x na nakakasatisfy na to mula dun sa domain. Ang nakakasatisfy lamang sa kanya ay si x equals 2. So isa lang yung i-check natin, yung f of x minus f of 2 ba when x is equal to 2 is less than epsilon. All right? But since at x equals 2, the minuend and the subtrahend are the same. So ibig sabihin, itong difference ito ay equal kay 0, and that's less than epsilon, obviously. So we can say that f is continuous at 2. All right? And this proof can be extended to any discrete set. Kapag meron kang isang discrete set na merong definitive distance between two consecutive elements, all right? Piliin mo lang laging delta, yung delta, piliin mo lang as delta yung number na sure ka na hindi ka lalampas doon sa pinakamalapit na neighbor. Okay? So what I'm trying to say is, halimbawa, ang domain mo ay 1/2, 1/3, pabaliktad, sorry. Sige, 1, tapos 1/2, tapos 1/3, tapos 1/4, tapos 1/5, and so on. Okay? Tapos gusto mong tingnan yung limit as kung continuous ba siya kay x equals 1 or kay x equals 1 half. So mag-work pa rin to kahit yung domain mo ay infinite na mga 1 over n yung domain niya. Piliin mo lamang yung delta to be that distance para hindi ka lumampas dun sa pinakamalapit mong kapitbahay. Para sure ka na siya lamang yung nag-iisang element ni x para yung f of x, element ni x na nandun sa domain na makakasatisfy ng delta inequality, alright? Para sure ka na yung f of x minus f of 1 half ay laging equal kay 0. Kaya nga siya isolated eh. Pipiliin natin yung delta so that 1 half will be isolated as the only element of the domain that belongs to that delta neighborhood. Dahil siya lang yung nag-iisang element ng delta neighborhood. Kasi nga pinili mo si delta to be small enough not to contain any other members of the domain. Ito lamang yung itetest mo sa f of x minus f of 0 or f of x minus f of 1 half. Tapos yung function value niya laging mag-i-equal kay 0. Okay? So yun yung pandaraya kung bakit continuous lagi ang ang isang function sa lahat ng kanyang mga isolated points. Kasi given any epsilon greater than 0, just pick your delta to be the distance, should be a small enough distance to isolate yung number under consideration. Okay? And with this in mind, nakakita na tayo ng isang function na continuous dun sa buong domain or sa lahat ng points dun sa kanyang domain na hindi natin kayang i-drawing yung graph niya without lifting our pen. Because anong graph nitong function f natin? Ang graph niya ay ganito. Oops. Ang domain niya ay 1, 2, at saka 3. Function value kay 1 ay 1. Function value kay 2 ay 3. Function value kay 3 ay 2. Ito yung graph ng function f. But we know that f is continuous all throughout its domain, meaning it is continuous at every number in its domain, and yet we cannot draw its graph without lifting our pen. And actually, that's the price we had to pay pag tinanggal natin yung requirement na siya ay defined sa isang open interval. Kasi kung open interval yan, wala tayong choice. Dapat ma-connect the dots yan para maging continuous. Pero if the domain is discrete, or consists of isolated points, then there's still a chance that your function will be continuous, even though the graph cannot be drawn without lifting our pen. Okay? So, bizarre as it might sound, but does the concept make sense? And how this generalizes our Math 36 notion of continuity? Okay lang ba? Or ayaw nyo siyang tanggapin? Actually, nadulas nga ako kanina eh. Parang hindi ko siya tatanggapin. Gusto kong isingit yung requirement na si x sub 0 ay accumulation point para siya ay maging continuous. Pero syempre susundin ko na lang si Abbott. Ganito kasi dinefine ni Abbott yung continuity. So sige na nga, pagbigyan natin si Abbott. Pero I think if I put the restriction that x sub 0 is a limit point, then para ma-define yung continuity, then I think mag-hold pa rin yung continuous yung function if and only if its graph can be drawn without lifting our pen. Because if that's the case, then hindi natin pwedeng pag-usapan yung continuity nitong function f na to kasi yung continuity ay defined lamang para sa limit points. And obviously, isolated points, by definition, are not isolated points. Ano sabi ko? Isolated points are not limit points. Okay? So, pero yun yung pinagkaiba. All right, so moving on, speaking of continuity over its domain, masasabi natin ng isang function ay continuous sa isang set kapag ito ay continuous sa lahat ng points ng set E. Okay? Continuous siya sa set kapag continuous siya sa lahat ng members ng set na yon. And we usually write continuity as this guy. So f, I usually read this as f is continuous on the set E. Pero pwede mo itong tingnan kung medyo formalist ka, f is an element of the set of all continuous functions on the set E. But basically, that's the notion. F is continuous on the set E. Okay, so let's see. Example 3.6, let's consider the function defined on this closed interval, 0 to positive infinity, so the set of all non-negative real numbers. And our function is our favorite so far, the square root function, kasi siya yung medyo kakaiba mula dun sa Math 36. Na-etsapera kasi siya sa Math 36, so ngayon tayo babawi sa 155, right? So sa kanya tayo medyo nagpo-focus as far as examples are concerned. Now, here the problem is to show that f is continuous on the closed interval 0 to positive infinity. Okay? So, para mapakita na ito ay continuous, kahit na anong number dun sa domain, gagamitin ko lang yung definition, pero gagamit ako ng arbitrary point x sub 0. Kasi gusto kong mapakita siya ay continuous doon sa kanyang domain. Dun sa definition natin, specific yung x sub 0. Pero ngayon, treat ko lang si x sub 0 to be an arbitrary member of the domain. So basically, our x sub 0 here will be any non-negative real number. So let's do the PA again. Tapos, pwede nyo na lang basahin dun sa lecture notes yung pagkakasulat ng actual proof, right? So kasi ang gist naman ng mga proofs involving limits, continuity, involving those two guys are always on the PA, right? So again, our PA will start by assuming an epsilon greater than 0. And the goal is to find a delta such that, or delta greater than 0, such that for all x in the domain, which is 0 to positive infinity, we have the absolute value of x minus x sub 0, that wala x sub 0, for any x sub 0 on the domain, the delta inequality always implies the epsilon inequality. Ano nga yung tawag sa function? F ba? Oh yeah, it's F. Minus f of x sub 0 minus epsilon. Again, the epsilon inequality just will not just involve any arbitrary L, but it is the function value at x sub 0. Okay? So this is our goal. Now, from here, okay. So, ito parang wala na tayong masisimplify dyan kasi hindi natin alam yung x sub 0. So, we'll keep it like that, all right? So, ang goal natin, itong left-hand side na to, masulat siya involving x minus x sub 0 para mapalitan natin yon kung ano man yon by the value delta. Okay? Now, sige, let's try to manipulate it. So, I'll have absolute value of f of x minus f of x sub 0. Okay, use the definition of the function. So this is square root of x minus square root of x sub 0. And now we are in a quandary here. Paano ko yan ngayon isusulat na may x minus x sub 0? May panggulo ng mga radicals. So any suggestions? How can I go about it? How can I write it so that it will have x minus x sub 0 somewhere? Bawal tumingin dun sa handout. So, try to think, ano? Para masanay kayo na, pag nagpa-quiz si sir ng ganito, hindi ko na kailangan pumunta sa math exchange para masagot itong simpleng question na to, ano? So, any technique that you remember how to deal with radicals or how to get rid of radicals? Actually, technically not get rid of radicals. Pero yan, yes, go Prince. Keyboard warrior ka pa rin ba? So yeah, type your answer there on the chat box. Habang nagta-type si Prince, duplicate ko na to. Okay, thank you, Prince. That's right. We need to multiply this guy by its conjugate over its conjugate, right? Just to edit ko lang yung sinabi mo. I-qualify ko siya. Pag nag-multiply ka ng conjugate lamang, hindi na yun equal dito. But I know what you're saying. You want to multiply it by conjugate over conjugate, right? So multiply mo to ng conjugate niya, which is absolute value of x, absolute value of the square root of x plus square root of x sub 0. Actually, you can just drop the absolute value because we know that the sum of these two radicals is positive. So pwede mong tanggalin yung absolute value. But I'll just leave it there for posterity. Actually, sige na nga, tatanggalin ko na siya dun sa next step. So remember how to deal with radicals. This will just be x minus x sub 0 over root x plus the root of x sub 0. All right? This guy is still in absolute values, right? And then we're fine because the numerator can be replaced by delta. And we know that delta is larger than this guy. But remember, our goal is to get a larger number. Kasi nga gusto ko less than yan eh. So dapat palakihin ko yung fraction dito sa huling line, right? So increasing the numerator will also increase the fraction. But to still guarantee that the number that we get is larger than the original one, we want to what? We want to decrease the denominator. So gusto kong paliitin yung denominator. So there are several ways on how to make the denominator smaller, but the appropriate one for us is to what? The most appropriate for us is to just drop the absolute value of the square root of x. Kasi ito ay yung variable pa to eh. Si x ay element lamang ng domain. Alright? Pero si x sub 0, specific to. Ito yung mga points kung saan tinetest natin yung continuity ng isang function. Remember, this is just our arbitrary way of checking if your function is continuous at every x sub 0 in the domain. So that means x sub 0 is a fixed element of the domain. Yun nga lang, arbitrary siya, pero fixed siya all throughout the proof. Isa siyang element ng domain, pero all throughout, siya yung same element. Unlike x, si x ay nagbabago, variable yan. Meanwhile, x sub 0 is fixed. So if I'll just delete square root of x from the denominator, and since this is positive, deleting it will make the denominator smaller. And a smaller denominator means a larger fraction. So we're sure that this guy is larger than the previous one. Okay, and then we want this to be less than epsilon. So we force that delta over square root of x sub 0 is less than epsilon. So that means if we are given an epsilon greater than 0, our choice for delta would be what? Tama ba yung sinulat ko? Pinaliit ko siya. The thing here is, dito pala magkakaroon ako ng restriction. Kasi iniwan ko na si square root of x sub 0 sa denominator. X sub 0 is any fixed element of the domain. But I will have a problem kapag si x sub 0 ay equal kay 0. Kasi kapag si x sub 0 ay equal kay 0, then that means delta over 0 less than epsilon, which cannot happen because delta over 0 will be undefined. So here what we'll say is that if x sub 0 is not equal to 0, then we choose delta to be equal to square root of x sub 0 times epsilon, which is perfectly fine for us. And then the formal proof will follow case number 2 here. Siya na yung makikita nyo dito sa handout. All right? But the case of x sub 0 being equal to 0 should be looked upon in a separate way. Kasi nga unang-una dun sa PA dapat napansin na natin kagad na mag-work lang to kapag si x sub 0 ay hindi 0. Because we will get this expression less than epsilon, which won't make sense if x sub 0 is equal to 0. And actually, yung choice din ng delta, makikita nyo rin na kapag si x sub 0 ay equal kay 0, mali na yung choice for delta. Kasi kung ito lang yung delta na gagamitin mo dun sa buong proof, alright, pero si x sub 0 ay posibleng maging equal kay 0, you will be telling your reader na delta equals 0, but that doesn't make sense because the definition requires delta to be strictly greater than 0. So there are several indications na magsasabi na hindi pala pwedeng kuning x sub 0 C0 for this particular choice of delta. So probably you'll need a different preliminary analysis kapag ka si x sub 0 ay 0. So pero iba naman yung case na yon. Ang PA natin ngayon kapag ka si x ay equal kay 0, we'll have absolute value of x minus 0 is less than delta. All right? Gusto nating i-imply niyan yung square root of x minus square root of 0 less than epsilon. But that's easy because the delta inequality tells us that the absolute value of x is bounded by delta. And then this guy, ito ay absolute value lamang ng, square root lamang ng x. Less than what? Less than square root of delta. Tama ba? Kasi dun sa delta inequality, alam natin ang absolute value of x ay less than delta. Take the square root of both sides, which is fine because both are positive. We'll get this guy. And then, para mangyari to, we will force that square root of delta is less than epsilon. So if you're given an epsilon, we can pick delta to be any number less than or equal to epsilon squared. Kaya dun sa part 1, yung proof, pinili niyang delta ay si epsilon squared. So makikita nyo, valid na yan kasi si epsilon ay greater than 0. So si delta ay mafo-force to be greater than 0. Unlike in this particular case. Kaya kailangan mo talagang ihiwalay yung case ni x sub 0 equals 0. Okay? So that completes the proof na continuous siya on the closed interval 0 to positive infinity. But this is still this is consistent dun sa continuity natin sa Math 36, which involves left hand and right hand limit. Kasi doon sinabi rin natin na okay, kahit hindi nag-exist yung limit ni f of x equals square root of x at x equals 0, continuous pa rin siya sa kanyang domain. Alright? Kasi nga kapag ka meron kang continuity on a closed interval, requirement lamang yung continuity from the right of the left endpoint and continuity from the left of the right endpoint para maging continuous siya sa isang closed interval. Okay? But you see that in the way we define continuity in Math 155, napaka-generic na siya. Hindi mo kailangan yung left-hand limit at saka right-hand limit. Okay? So let me see what's next. Okay. Now, may tanong ba doon? Okay. Keeping our tradition of always relating functional limits to sequential limits, pwede rin natin itong gawin sa continuity. Alright? Pero paano natin i-characterize to? Kasi wala tayong define yung notion ng continuity ng isang sequence. Alright? So tingnan natin paano natin to maisusulat na may equivalence, katulad ng Theorem 3.1 sa limit ng sequences. Okay? Now, for that, we have Theorem 3.3, and it tells us if f is a function defined from E to R, and x sub 0 is a limit point of E. So ito, requirement na si x sub 0 ay limit point na ni E. Doon sa original definition ng continuity, walang requirement na si x sub 0 ay limit point. Pero dito sa characterization, dapat limit point si x sub 0 because gagamitin uli natin yung convergence ng mga sequences. At para ma-sure na meron kang sequence na nagko-converge kay x sub 0, dapat siya ay limit point ng ating set o ng ating domain. Okay? So here are 3 equivalent statements sa pagiging continuous ni f kay x sub 0. Okay? Or actually, at least one of these 3 guys must hold para ma-conclude na si f ay continuous and conversely. Okay? Una, this is basically our definition of continuity at the number x sub 0, so nothing more than the definition. Then sa number 2, ito yung Math 36 criteria nyo. Limit ng f of x as x approaches x sub 0 ay equal kay f of x sub 0. But mind you, yung gagamitin yung definition dito sa limit na to ay yung Math 155 definition. Alright? Pero yun nga, parang kamukha na siya nung nasa Math 36. Tapos ito yung sequential criterion. This ties up continuity of a function with a certain test para sa sequences. Alright? So sinasabi nito ay, kapag kumuha ka ng kahit anong sequence doon sa domain na nagko-converge kay x sub 0, and you will see here why we needed x sub 0 to be a limit point. Kasi kapag siya ay limit point, automatic na may makikita kang sequence dun sa domain na magko-converge papunta kay x sub 0. Alright? So, magiging continuous ang isang function kay x sub 0 kapag kumuha ka ng kahit na anong kumuha ka ng kahit na anong sequence na nagko-converge kay x sub 0, then laging mag-imply yon neto. The convergence of the sequence of function values papunta dun sa function value. Alright? So, meron kang mga x's, sequence ng mga x's na nagko-converge kay x sub 0. Tapos, magbuo ka ngayon ng pangalawang sequence. Ano yung pangalawang sequence na bubuin mo? Yung sequence ng mga function values. So, may bago kang sequence. F of x1, f of x2, f of x3, f of x4, and so on. And see, saan nagko-converge yung sequence na yon? Pag nakita mo yon ay nag-converge kay f of x sub 0, and this happens for any sequence, then you are sure that f is continuous at x sub 0. So basically, in a nutshell, continuous yung function kay x sub 0 kapag kahit na anong sequence na nagko-converge kay x sub 0 ay manganganak ng isang sequence, yung sequence ng function values na nagko-converge doon sa function value ni x sub 0. Okay? But that's hard to use because you should be able to show na mangyayari yon sa kahit na anong sequence. Pagka halimbawa nakabuo ka ng isang sequence, napakita mo yung sequence of function values nagko-converge dun sa function value, that is not enough to conclude continuity because ang usapan sa number 3, dapat mag-hold yan kahit na ano pang sequence. Kasi posibleng makakuha ka nga ng sequence na nakakasatisfy niyan, tapos isang sequence na hindi naman nagko-converge yung sequence of function values kay f of x sub 0. Okay? And actually, that's our criterion for discontinuity. Mas madaling gamitin yung negative nung statement 3 kay theorem 3.3 for discontinuity. And basically, it just tells us na kapag nakahanap ka ng dalawang sequences dun sa domain na nagko-converge kay x sub 0, ngunit yung function values or yung sequence ng function values ay hindi nagko-converge kay f of x sub 0, then automatic yung sequence mo ay discontinuous. Sorry, hindi pala kailangan ng dalawa. Isang sequence lamang dun sa domain na yung sequence of function values ay hindi magko-converge kay f of x sub 0. And that's enough to conclude discontinuity. All right? So, laging bumabalik tayo sa konsepto ng sequences, and that would be the common theme for the remainder of the unit. Pagpatuloy natin 'yan hanggang sa dulo. Okay? So, halos lahat ng konsepto sa sequences mabibigyan natin ng counterpart para sa continuity para sa limit ng functions. Okay? Now, let's see corollary 3.4 in action through example 3.7. And in this particular case, we want to show that the set of points of discontinuity of the floor function is the set is z, right? The set of all integers, right? So the domain of the floor function yan, I r, because the function is just simple. It rounds down any real number. Okay? Kaya ang tawag sa kanya ay floor kasi lagi mo siyang binababa to the integer that is to the greatest integer smaller than or equal to your number x. Diba, meron kang floor ni 1. Ang floor ni 1 ay 1 kasi i-ignore mo lang naman yung decimal digits. Pero pag meron kang 1/2, kinuha mo yung floor niya, kukunin mo yung pinakamalaking integer na mas maliit sa kanya. Alright? So ano ba yung mga integers na mas maliit kay 1/2? You have 0, you have -1, -2, -3, -4, -5, and so on. But what is the biggest among those integers? The biggest among those integers is 0. So ganun natin kinukuha yung floor function. It is the greatest, or this is the integer the greatest integer that is less than or equal to the given number. Pero computationally speaking, ito lamang yung nag-ignore ka lang ng decimal digits. So, halimbawa, floor ni 1.5, ito ay equal kay 1. Pero just be careful sa mga negative numbers, sa mga negative 0.38, you always round down. So, ito ay equal kay negative 1. Okay? So, ganun nag-work yung floor function, and it seems that, or actually, it doesn't seem, siya ay obvious na nag-work siya kahit sa anong real number. Okay? Tapos ang usapan dito sa example, ipakita daw natin na discontinuous yung function na to sa lahat ng integers. At yun lamang yung points of discontinuity, right? So dalawang parte yung proof. Una, ipakita natin na discontinuous yung floor function sa kahit na anong integer. Okay? So mag-consider tayo ng integer x sub 0. Okay? Tapos ipapakita natin, or actually not m, ginamit dito sa lecture notes ay m. So mag-consider tayo ng isang integer m, tapos pakita natin na discontinuous yung function. Now, the criterion for discontinuity tells us na kailangan lang nating makahanap ng isang sequence mula kay R na nagko-converge kay M, pero yung function value ng mga xn ay hindi nagko-converge kay f of m. Okay? But since m is an integer, ibig sabihin yung floor ni m ay equal sa sarili niya. Kung siya ay integer, ang floor niya ay sarili niya. So ito yung idea pala natin. Kailangan nating mag-construct ng isang sequence ng mga x's na nagko-converge kay m, pero dapat yung sequence ng mga function values ay hindi magko-converge kay f of m, which is equal to m. Alright? Now, medyo maganda yung ginawa nung sa handout. Napaka-simple nung pinili niya sequence. Sinong sequence yung pinili niya? Sequence na m minus 1 over n. Tapos, nakita na ako sa mga homeworks na maraming pumipili na nito. Alright? Alam nyo na yung trick. Kapag gusto mong merong isang sequence na mag-convert sa isang number, kunin mo lang yung number na yon, tapos mag-minus ka lang ng 1 over n. Or mag-add ka lang ng 1 over, mag-add ba ng 1 over n? Hindi pala pwede mag-add. Mag-subtract ka lang ng 1 over n. Okay. Tama ba? Yeah, pwede ka pa rin pala mag-add ng 1 over n. Magko-converge pa rin siya kay m. Right? Pero ang pinili niya, nag-minus siya. Okay? Makikita natin mamaya kung bakit hindi mag-work yung m plus 1 over n. Pero maganda yung m minus 1 over n kasi obviously, magko-converge yan kay m. Tapos, kunin natin yung itsura ng mga f of x n. Right? So, ang f of x n ay equal kay m minus 1 over n. I-plug natin yan into f. Kukunin ko yung maximum. Alright? Yung pinakamalaking integer na mas maliit kaysa kay m minus 1 over n. So, kung siya ay m minus 1 over n, ibig sabihin siya ay m minus 1 plus some fraction. Right? So, definitely, ito ay mas maliit na kay m, pero mas malaki pa rin siya kay m minus 1. Right? So kasi kung titingnan nyo, parang ganito siya. Ito si m, tapos andito yung mga m minus 1 over n. M minus 1 over n. Nasa kaliwa siya ni m. Tapos pag kinuha mo yung graph nung floor function, so kapag ka si m, ang function value na ay m, pag lumampas ka kay m, ang function value niya ay si m pa rin, kasi nga nag-round down ka lang. Tapos ito ay si m plus 1. Pero kay m minus 1, okay? Mula kay m minus 1, papunta kay m, ang value niya na ay m minus 1. Tama? Lahat ng mga elements ng sequence natin, yung mga m minus 1 over n, naninirahan sa interval na to. Alright? And it is easy to see that the function value of m minus 1 over n under the floor function is basically m minus 1. Alright? And that is not equal to the function value of m. The function value of m is m. Right? So nakakita tayo ng isang sequence na nagko-converge kay m, pero yung sequence ng function values hindi nagko-converge kay f of m. Alright? So that means, yeah, indeed, this is continuous. F is discontinuous on any integer. Okay. Sir, yung m plus 1 over n ba mag-work? Actually, it won't. Hindi mag-work yung sequence na x plus 1 over n. Although the sequence, m plus 1 over n. So yung sequence sa m plus 1 over n ay magko-converge kay m, alright? Kasi decreasing yung sequence. Pero palapit siya ng palapit kay m. Ang mangyayari doon, yung mga m plus 1 over n ay nandito sa kanan ni m. So ibig sabihin yung function value ng m plus 1 over n under the floor function is equal to m kasi round down nga tayo. Okay. Pero ang function value therefore ng m plus 1 over n ay equal kay f of m, which is m. So therefore, hindi siya sufficient to draw any conclusion. Hindi ko pwedeng masabi na siya ay continuous kay M kasi nga dapat dun sa theorem 3.3 dapat totoo to sa lahat ng sequences. So showing one sequence satisfy statement number 3 of theorem 3.3 is not enough. Alright, dapat pakita mo siya na to siya. Pero yeah, we already saw that that is false because we have constructed a sequence satisfying or that contradicts theorem 3.3.3. Okay? So yun yung yun yung proof na discontinuous to sa lahat ng integers. Okay? And I hope this will give you a clue dun sa homework. So medyo similar dito yung nasa homework niya, right? Kaya lang ano nga ba yun? Continuity limit lang yun, no? Pero this might give you an idea how to do that, right? So medyo mabigat pala yung Layman theorem 3.7 because it tells us na okay, ang set of points of discontinuity ay z. Ang napakita pa lang natin ay si z na yung points of discontinuity ay subset ni z. Gusto nating ipakita na wala ng ibang points of discontinuity. Right? So ibaliktad. Ang napakita natin ay si z ay subset ng points ng set of points of discontinuity. Ang gusto ko ipakita wala ng ibang points of discontinuity aside from the integers. Okay. So ang ginawa naman ngayon ay I think this is direct proof, right? So direct proof na para ipakita na continuous yung function sa lahat ng mga hindi integers. Okay? So kumuha siya ng isang x sub 0 na hindi integer. Okay? Tapos alam natin na okay, dahil isa yung real number, napapagitnaan niya ng dalawang integer, right? So it will lie between some n and n plus 1, right? It will lie between two consecutive integers. Tapos kapag binigyan ka ng epsilon greater than 0, piliin mo lang si delta to be the minimum between x sub 0 minus n and n plus 1 minus x sub 0. Ito yung para hindi ka lalampas dun sa kabilang bakod. Alright? So kasi ang drawing naman dito ngayon, ito si n, ito si n plus 1, right? Ito yung given x sub 0 natin na hindi integer, right? So dahil hindi siya integer, sure tayo mapapagitnaan niya ng dalawang integer. Pag binigyan ako ng epsilon, ang pipiliin kong delta ay small enough para hindi ko makover yung n o kaya yung n plus 1. Okay? Kasi sure ako sa neighborhood na to, pare-parehas yung function values, right? Kasi kung i-graph niyo uli, ang function value dito ay n. At tama ba? Yeah. Simula dito, hanggang dito ang function value ay n. Pero starting from n plus 1, pataas, ang function value niya na ay n plus 1. Alright? Kung nandito si x sub 0, piliin mo lang si delta small enough so that pare-parehas yung function values nila. Kasi kung pare-parehas yung function values nila, yung f of x minus f of x sub 0 will be equal to 0 and that is less than any epsilon that is greater than 0. Alright? So ito lang, piliin mo lang yung delta to be small enough na hindi ka lalabas ng interval n to n plus 1. And one way to do so is to choose delta to be the minimum between the distance between n and x sub 0. Yung distance na yon ay ito. And Ito naman yung isa pa, kukunin yung minimum between these two guys. Yun yung n plus 1 minus x sub 0. Kasi pag ganun mo pinili yung delta, ibig sabihin sure ka na hindi ka lalampas ng n at hindi ka lalampas ng n plus 1, makukulong ka lang dun sa pagitan ni n at saka ni n plus 1 kung saan pare-parehas yung mga function values. And that's why we get this easy epsilon inequality. So indeed, wala nang ibang points of discontinuity yung floor function. So discontinuous lang siya sa lahat ng mga integers. Alright? So, pero I trust na kung ginawa niyo na yung homework, alam niyo na kung paano nag-work to. Kasi sa homework nga ba, greatest least integer less than or equal to naman yung, greater than or equal to naman yung pinagawa ko. Ceiling function naman. So, yeah. Tiniming ko talaga yan para ma-reward kayo mga umattend ngayon ng lecture para magkaroon kayo ng idea paano gagawin yung sa homework. Okay. Meron pang 10 minutes pero pagod na ako. Hindi ko alam kung ano nangyari. Let's see. Bilis ko ba magsalita ngayon? Parang napagod ako. Naramdaman ko na yung stress sa lalamunan. Hold on guys. 2-minute break. Mukhang uulan na naman dito sa amin. So, sana tumuloy siya pero sana buong hapon. Kasi minsan, pampainit lalo yung pahapyaw na ulan, ano? Pero ang problema ko pag umulan, baka humina na naman yung internet signal ko. Oh darn, I forgot one thing, sorry. Na-press ko ba yung record? Yeah. Thank you, thank you. Kinabahan ako, akala ko hindi ko na-press yung record. Kasi dun sa section X, one time nakalimutan ako mag-record. So, reading assignment na lang yung natitira, pagod na ako. Joke, nagreklamo eh. Hindi, ano lang naman to. Mabilis lang naman to. All right, so going back. Pero ramdam ko talaga. Anyway, Theorem 3.4, Algebraic Continuity Theorem. Pero alam niyo na naman to, mula sa 36, ganun din to. Kf is continuous. Any scalar multiple of a function, of a continuous function is continuous. The sum of two continuous functions is continuous. The product of two continuous functions is continuous. And the quotient of two continuous functions is continuous, provided that f over g is defined. Okay? Now, the proof of Theorem 3.4 will rely on Theorem 3.3. Okay? Kailangan nyo lang i-reason out yung relation between continuity of a function and the convergence ng dalawang sequences. Yung sequence ng mga domain elements at saka sequence ng function values. Okay? Tapos gagamitin nyo yung results from Unit 2 para ma-prove yung continuity. Okay? Kaya ko ba itong gawin? Sige na, gawin natin to. Pili kayo ng isa. Actually, it doesn't matter naman kung alin sa kanila, right? Kasi ganun din yung magiging proof nung natitirang tatlo. Perhaps let's try item 3. Maiba naman. Kasi lagi tayo item 1 ang ginagawa. Sa item 3, ang product ng dalawang continuous ay continuous. Okay? Sa isang number x sub 0. So that means since sketch na lang ng proof, kayo na lang yung mag-formalize. Since f and g are both continuous on the set containing x sub 0, then by theorem 3.3, okay, for any sequence xn that converges to x sub 0, all right, we have f of xn converges to f of x sub 0, and g of xn converges to g of x sub 0, right? So ito yung sinasabi ng characterization natin kanina, na kapag continuous ang isang function, therefore, kahit na anong sequence dun sa domain na nagko-converge papunta kay x sub 0, yung sequence ng mga function values nila ay magko-converge din kay f of x sub 0. Eh si f at saka si g ay parehas continuous, so itong dalawang to ay nag-hold. Tapos gusto ko kasing i-investigate yung continuity ng f times g. So I would like to see how an arbitrary sequence of function value, a sequence of product of function values will also behave. All right? Pero ang gagawin ko lang dito, magko-construct uli ako ng panibagong sequence. Then the sequence, may panibago akong sequence dito. Yung sequence ng mga f of xn times g of xn. Okay? Oh, sir, alam ko na yan. Sequence ng f of xn times g of xn. Sabi natin dati kapag meron akong dalawang sequence sa convergent, tapos gumawa ko ng isa pang panibagong sequence consisting of the product of the corresponding elements or terms of the original two sequences. Yung sequence na bago na yon ay magko-converge dun sa product ng limits ng dalawang sequences na nauna. So basically, this will just converge to f of x sub 0 times g of x sub 0 by theorem 2 point something. All right, so by theorem 2 point, nakalimutan ko yung number, all right? Or you can just say by one of the algebraic limit theorems for sequences. Okay? Tapos, same template. Okay. Ano ngayon? Kung totoo ito sa kahit na anong sequence, well, gamitin ko ulit yung theorem 3.3 para i-convert ito pabalik doon sa sequence ng at doon sa limit ng isang function. So dahil ito ay totoo sa kahit na anong sequence ng mga xn na nagko-converge kay x sub 0, therefore we can say that f times g is also continuous at the number x sub 0. End of proof. Okay? Kung nasa Math 36 lamang tayo at wala tayong konsepto ng Theorem 3.3 at saka ng limits and sequences, this will require a tedious manipulation of the epsilon and the delta inequalities. So you see the utility ng mga results na nabuo na natin at yung interconnection between limits of sequences and limits of functions. Okay? Now, with this algebraic continuity theorems, we can now observe and say that polynomial functions are continuous as well as rational functions over their domain. Okay. All right. So if I ask you to prove one of these remaining three theorems, kakayanin ba? Dapat kaya na, ano? All right, so I think last hura na to talaga, composition of continuous functions. So, ito naman essentially ang gist nito ay kapag meron kang continuous function, continuous din yung composition, pero under some additional assumptions. So, consider ka ng isang function f na ang domain ay A, tapos isang function g na ang domain ay B. Tapos remember paano nag-work ang composition kapag meron kang g circle f of x? Ang nangyayari lang dyan yung f of x, computein mo muna, tapos yung sagot, siya yung ipapasok mo dun sa function g. Alright? So you evaluate f of x first, and then whatever the answer is, you plug it into g. So that means we need to require that the set of function values of f should be a subset of the domain for the composition to be well-defined. And so that's what we write here. Dapat yung image ng mga elements ni capital A ng domain ni F under F ay dapat elements ni B rin. Para maging well-defined yung G of F of X. So dapat ito ay nandun sa domain ni G. Okay? Then we say that if F is continuous at X sub 0 and G is continuous at F of X sub 0, then G circle F is continuous at x sub 0. Alright? So, ito yung chain of events na dapat mangyari. Bakit natin nire-require na si G ay maging continuous sa f of x sub 0? Kasi kapag kinompute mo yung G circle F of x sub 0, gagawin mo siya by plugging in x sub 0 first into F, and then the answer, which is f of x sub 0, must be plugged in into G. Okay? Now, is it okay, guys, if I leave the proof as a reading assignment to you? Medyo hindi ko na kayang ipagpatuloy pa. So, okay, if you're having troubles understanding the proof kasi nga isang paragraph lang talaga yung proof, visit my Math 155 playlist from last semester. Puntahan niyo yung video about continuity. So, dun sa dulo, hanapin niyo yung proof nito. So, I discuss it there. Actually, inisip ko nga, bakit pa nga pala ako nagpapakahirap? Pwede nga gawin ko ay open ko yung meeting, tapos share screen ako, i-play ko na lang yung video ng recording from last semester, no? Kasi naman, di rin kayo masyadong sumasagot eh. Pero anyway, nakita ko naman nag-effort naman kayo whenever you can na mag-participate. So, it's fine. Saka masaya na mag-discuss live, ano? Okay, so any questions or concerns? Kaya pasensya na guys, napagod ako ng maaga. Tapos may klase pa ako ng 2:30 dun sa kabila. So kailangan ko muna magpahinga. Baka bukas wala na akong boses sa 175. Okay? So if there are no questions, then thank you guys for coming today. Yeah, homeworks due later tonight. And then probably problem set number 2 will be given end of next week. Tapos, ano pa ba? Yeah, and we'll meet again on Thursday, right? So until then, ingat kayo guys. Bye-bye.